Now, so far, we've looked at addition, subtraction, simplifying rational expressions. We've looked at a lot of different parts of rational expressions. And the last thing we're going to look at is solving rational equations. We're going to look at solving rational equations. Now, it says we're going to solve rational equations by cross-multiplying. Well, no, I'm going to cross that out. I don't like the idea or term of cross-multiplying. It is a very easy way to teach multiplying fractions that's not, it's more of a trick than actually learning how to do it. So, we're going to look at this here. Now, we could do what they're calling cross-multiplication. I don't like that term. I don't really like how it's used because it gets confused if you're not used to using it or kind of knowing what it is. What we're really going to do is kind of look at this here and see, well, I'm going to multiply everything so that the denominators simplify. I want to simplify the denominators of these fractions. I don't want to have fractions throughout this equation. Now, if we look at this one here, 9 over 4x plus 5, what do I need to multiply this by so that the denominator would simplify out? Because if I multiply this by 4x plus 5, well, the 4x plus 5 over 4x plus 5 would simplify, yes? Well, what would I need to do to this fraction over here? Because if I multiply this one by x plus 1, those would simplify out, yes? But I can't do just x plus 1 to one side of the equation and 4x plus 5 to the other. We have to do it to both. This is the essence to cross multiplication, because if I do this, let's see what happens. Well, with this multiplication, will the x plus 1 and x plus 1 cancel, yes? And what does that leave us with? 4x plus 5 times 3, yes? And over here, well, the 4x plus 5 and the 4x plus 5 cancel, leaving us with 9 times x plus 1. This is what is cross multiplication. This is what you're actually doing, but normally, and for some reason, most just say, well, we're going to multiply like this and simplify down. Well, that's what we got, yes? So sometimes instead of trying to go through the full explanation, we're multiplying both sides by what's on the bottom of each fraction. Canceling out, we're just going to cross and go that way. So really what we're doing is we're multiplying both sides of this equation, or everything by this equation, so that all the denominators cancel out. Now, before we do this, here we're good, because 4x plus 5 and x plus 1, those are simplified as they get, yes? 4x and 5, there are no greatest common factors. X plus 1, there's no greatest common factors, yes? So we didn't have to worry about that. But if there are greatest common factors, we want to simplify them out because it's going to make it easier to work with. Okay. Any questions on this here so far? Are we good with this here so far? Okay, let's go on and solve this here. Well, to solve this, well, I'm going to have to distribute the 3. 3 times 4x is? 3 times 5 is? Do the same thing on the other side. 9 times x is? Plus? Okay, what do we do next? We got to get x on the same side, yes? And everything else on the other? Okay. Pause it just for a second because there is a 9 and a 9x.
Yeah, I cleared it up.
All right, so we can do subtract 9x because those will cancel. 12 minus 9x would be plus 15 is equal to, okay? Yes, then we would subtract the 15 because, again, we want to get x by itself. because 15 minus 15 would be 0, leaving us with 3x is equal to, divide both by 3. And so it tells us x is equal to -2. Any questions on this here? Okay. Well, wait a minute. What is one thing that we've always been talking about with any of these rational expressions? Restrictions, yes? So if we look back at this original equation, I'm going to erase all this here, at least as much as I can. So we can look at this. Well, the x plus 1 tells me x cannot equal what? -1. And the 4x plus 5, if we work this out, cannot be negative. And what did we say x was? Is -2 one of our restrictions? No, so can it work? It will work. Now, if I wanted to, what we can do is we can check it. Get rid of all that. And the way we can check it is just by plugging it in like we've checked before. 3 over -2 plus 1 is equal to 9 over 4 times -2 plus 5. So this would be -1. 4 times -2 would be -8. Plus 5 is -3. And yes? We tell us -3 is equal to -3. It works. So a lot of the times, actually having the restrictions will help us figure out what x cannot be. So if x turns out to be one of the restrictions, it means that value does not. What happens if all of my values, so let's say x wasn't, for some reason we had x is equal to -1 and -5/4 were our two solutions. Well, 0 is actually a solution because we can have x equals 0. But I mean, in this case, like you're saying, yes, it can't be -1 and it can't be these here, right? Because those are all my restrictions. Well, how many do I have left? This would be. So it is possible to have a no solution because all the values that you end up getting cancel out or are part of the restriction, so they don't work. Because we had that with quadratics, right? And we've dealt with that before where we got answers, but those answers didn't work in the equation. So it is possible to get no solutions. Okay. Since the no solutions, or not no solutions, since the restrictions are kind of helpful, yes? Because knowing the restrictions kind of helped us out, knowing what the solutions could not be from the beginning, yes? Well, I can get them from the beginning. I didn't have to wait. We're looking at this here. We know x cannot be what? Or? Because for the 3x plus 2, if we wanted to solve it, well, we would subtract 2 and then divide by 3, yes? I think y'all are wishing that we went back to solving those again. Okay, so that takes care of that. So if we know, so now we know if we get -2 or -2/3, those solutions don't work. We don't even have to check them. We know that they will not work. Because if it's one of these two, it's going to make one of these denominators be 0. We cannot have it be 0. Okay, what do we do next? What can we do? So we multiply the 10 by x plus 2 and? Yes. Because essentially what we're using here is called the least common denominator. We're using a number or sets of monomials or binomials here, binomials, to simplify the denominators. We want these denominators simplified. Now, we can do this with multiplication. There's nothing wrong with doing this here with multiplication. Because here, x plus 2 over x plus 2 does simplify, yes? 3x plus 2 and 3x plus 2 simplify. Now on the left-hand side, we're left with 2 times 3x plus 2, yes? What happened to the x plus 2 over here? Is it gone? Well, it's gone, yes? Is it gone completely from this equation? No, it's on the other side, yes? And on the other side, I have 10 times x plus 2. Well, over here, the 3x plus 2 is gone from the right-hand side, yes? Is it gone completely from this equation? No, it's on the left-hand side, yes? That's why this still works, because we still have those terms still left in the equation, yes? We cannot divide something out. We cannot divide a variable out. Because if I divide a variable out, is it gone completely? Well, yes, because we divided it out. Y'all kind of see that there? So we can divide numbers across the entire equation, but do not divide variables because you lose solutions that way. So we have to be careful with that. Multiplication is fine, division is not. Yes. Okay, we're going to have to distribute again. Now 2 times 3x will give us 6x. 2 times 2 is plus. On the other side, we'll do 10 times x, which is and now what can we do? Yep. By? Okay, we can subtract 10x from both sides. Is 10x minus 10x would cancel. 6x minus 10x will give us negative 4x. Plus 4 is equal to 20. And then from here we can? Exactly, we can minus 4 from both sides. Let's put negative 16, it's just 16. X equals negative 4.
I ran out of check. Is that right? Because everything got taken out except 3.
Let me look at it here in a little bit.
Okay.
Now, is x equals negative 4 one of our restrictions? Well, no, so this works. Yeah, negative what? Negative 1, so it works. It's one of our solutions. Now here again, we can look at our restrictions, because for most of the ones that we're going to do today, the restrictions aren't going to come into play at all. But they will come up later, because there are going to be problems that we come across where one of our solutions will be one of the restrictions. So we can't have that. Now looking at this here, well, the 5x, our restriction would be, well, 0, because if I plug 0, 5 times 0 is 0. And our x minus 7 would be 7. Okay. Now what would be our first step in solving this? Which would be? Yes. And there will be a question on the homework that's going to ask you to find the least common denominator to solve the following equation. It's not actually asking you to solve anything. It's just wanting to know what is the least common denominator. And for this here, the least common denominator is 5x times x minus 7. That's it. So, because when we multiply through with this here, the x minus 7 and x minus 7 cancel. The 5x and 5x cancel, which leaves us with 3 times x minus 7 is equal to 2 times 5x. Any questions on how we got to this point here? Okay, now we need to distribute. 3 times x would be, 3 times negative 7 would be negative 21. And 2 times 5x is, now what? All right, we can subtract 3x from both sides, which would get those to cancel, leaving us with negative 21. And so last but not least, divide both sides by 7, and we get x is equal to negative 3. Is that one of our solutions? Nope. So that is it for that one there. Any questions on any of this here? We're good with this here? Yes? Let's see here. Yeah. Okay, walk me through this one. What would we do? Which would be? Yes. We multiply both sides by x plus 3 and x minus 3, because we know the denominators will simplify out if we do this. X minus 3 and x minus 3. X plus 3 and x plus 3. Which leaves us with negative 4 times x minus 3 is equal to 5 times x plus 3. Negative 4 times x would be negative 4x. Negative 4 times negative 3 would be plus, yes. Here you go. And now what? Right, we can add 4x to both sides, yes. 4x to 5x, those would cancel. Now we'd have 12 is equal to 9x plus 15. And then, subtract 15 from both sides. Well, we have negative 3 is equal to 9x. Divide each side by 9. That tells me x is equal to what? Negative 3/9, or really we can reduce that down to negative 1/3. Is that one of our solutions, or one of our restrictions? So we didn't list any of them here. But if we go back and look at our restrictions, x cannot equal what? So positive or negative 3. I call it plus or minus, whoops. Positive or negative 3. And negative 1/3 is not one of those. Questions on this here? We good with this here? Okay. Yes. I like this one. Yeah, that's normally how it works. Right, because that's our least common denominator. And again, we haven't had to look for it, so we're not really, probably it's not on the top of our head. But it's just making sure that these don't simplify at all. And they won't, because 11x plus 8, 11's prime, so it doesn't factor. 2 and 5 are prime. So this works. Huh? I mean, they've gotten, well, because they keep finding new primes. There have been proofs that state that there are an infinite number of primes. We just haven't had a way to prove that that's actually true yet. They have gotten rid of one prime number in the last so many years, I think 20 years, 30 years or so. Mm-hmm. Nothing. All right, let's keep working with this here. Our 2x plus 5 and 2x plus 5 would. 11x plus 8 and 11x plus 8 would cancel. And over here, we're going to have 1 times 11x plus 8. Which is going to be 11x plus 8. Over here, we're going to have x times 2x plus 5. Mm-hmm. And we distribute exactly 2x squared plus 5x. So what do we have now? We have a quadratic, yes? Because the x squared term turned it into a quadratic automatically, because anytime we have a power greater than 1, it's going to be a quadratic. So if we have a quadratic or kind of any higher degree polynomial, everything's going to the same side. Unless we don't have a middle term. Okay, well, we have middle terms. So we need everything on the same side. So I would. Yep. Not like. It is. We subtract the 8. Now, since there's no like terms with 8, well, that just gives us 2x squared minus 6x minus 8. And what would be on the other side? 0. Because again, when we get quadratics or higher degree polynomials, we want it to equal 0. Because if 2x squared minus 6x minus 8 is factorable, I can rewrite it as sets of parentheses being multiplied together. And if I have more than one thing being multiplied together, one of them has to be 0. Okay. Well, before we get too far into factoring, well, what do we know? Various common factors 2. 3x minus 4. Right? We can do 2 sets of parentheses because I think this one here is not too bad to factor. Okay? Opposite signs. Yes. So opposite signs because our third term was negative. Factors of x squared would be x and x. And again, yes, I agree. We would lean with 4 and 1 instead of 2 and 2. And x minus 4 and x plus 1 would be the factors. Now, we have multiple things multiplied together that equal 0, yes? Which means one of these has to be 0. So it's telling me that either x minus 4 is equal to 0 or x plus 1 is equal to 0. Well, we'd add 4 to both sides, and I think most of y'all know that we had a positive 4 and x is equal to -1. And that would be our solutions. And our restrictions for this here won't come into play because the two restrictions for this here are -5/2 and -8/11 are the two restrictions. So both of these work. Questions on this here? The reason I like this is we actually hit something of a degree 2, something a little bit more than just a linear multi-step equation. Any questions on this here? Yeah. So this isn't any more complex than what we've been doing. It's just we have addition with it. We have some more terms. Now, if I looked at each one of these terms individually, what would I need to multiply -9/x by to get the fraction to reduce? By x, yes? Okay. So I'm going to need to multiply it all by x. How about 7/4? 4, okay, I'll put a 4. And then we have 5/x, yes? So I'm going to need another x, right? Right? But how many x's do I need total? Well, how many x's do I have here? How many 4's do I have here? How many x's do I have here? How many x's do I have in any of these here? How many do I need then? Let's see what happens. So I'm going to have you watch this here, and then I'll give you a second to write this down. Is if we multiply everything by 4x squared, well, 4x squared times 5x. Well, one of these x's would cancel out with one of these here, yes? Let me just go on and write it. So we'd have 4x squared times 5 over x. Well, one of those would cancel, yes? And I'd have an x left on top. Plus, we'd have 7 times 4x squared. Well, 4 and 4 would simplify, yes? And over here, we'd have -9 times 4x squared over x. Wait a minute. So one of these will cancel out. 4x times 5. Well, 4 and 4 would cancel, so I have a 7x squared. Well, one of these would cancel out with this, and I have -9 times 4x. Wait a minute, I have an x in every term, don't I? Well, that'll eventually factor out, yes? Okay, I'm going to try this again. There's a reason I had you kind of watch that. We ended up with an x in every single term, yes? Okay, let's try this again. Instead of 4x squared, what happens if I do 4x? Well, 4x times 5 would be 5 times 4x. Let's write this one down. 4x times 7 would be 7 times 4x over 4. And here I'd have -9 times 4x over x. Well, here the x and x would cancel, yes? Here the 4 and 4 would. Here the x and x would. So what I'm left with here is 5 times 4, which is plus. Well, this here's the same. I didn't multiply the numbers, but we had, instead of 20, we had 20x. Instead of 7x, we had 7x squared. instead of negative 36, we had negative 36x, is what we really came up with. But all the variables canceled out, even if it was squared or just x, right? Well, in each one of those, how many times did x appear? Once, right? So we didn't need the extra x. Because I would use x squared as if, only if I had what? An x squared, if I had it twice. And I'll show you here on the side what would happen if we had that extra x. Now, let's solve this here. Well, what do we need to do? All right, so 7x. So 7x would equal negative 56. And then that there is our answer. Questions on this here? So are we good with this here? Yes? Now the other one was 3x plus 7x squared. So we multiplied by x squared, we would have gotten this here. Okay, well, since I have a quadratic, what I would do is I would add 36 to both sides, which would give me 7x squared plus 56x equals 0. So hey, they both have a greatest common factor of 7x, which if I factor it out would leave me with x plus 8 equals 0. Okay. Well, this one here would tell me x is equal to 0. Here tells me x is equal to negative 8, yes? Well, wait a minute, how did I end up with two solutions? Well, let's go back and check something. So looking at this starting equation, what are our restrictions? X cannot equal what? Okay, x can't be 0. Oh, that one doesn't work. So when multiplying with that x squared, we still were able to get to the solution. But wait a minute, it turned it from something over here where the degree was 1. Now we have a degree of 2. We just made it a little bit harder, yes? That's what we need to be careful with. That's kind of, I've been emphasizing it on and off the last few days about getting the smallest one. This is kind of why, because, well, especially when we saw it, I just added a restriction in. I added an extra number in. So if we end up doing this with quadratics, ending up adding more and more in, like if I had 3 in, that would have been a cubic or a quartic, and this is just making it harder. Y'all kind of see how that works there. So that's what we have to be careful with, and just making sure we get the least, the smallest one. So even if it appears more than once, as long as it only appears once in each of the denominators, we only need it once. How do we feel about these here? Y'all feel confident with these here? Okay. We'll stop here.